I think this graph is probably so darn basic. I probably can get away with not building sine graphs. After all, without that first term, that's just a sinusoidal wave. But now with that first term added back in, I'm just sinusoidally deviating away from the line y equals x. Well, here's the line y equals x. So it looks to me I'm probably doing something like this. And so I think the first critical number is going to yield my local max. The second critical number is going to yield my local min. I don't think I said that very well. I meant to say the first positive critical number is local max. The first positive, the next positive critical number will yield my local min. And then I can just add 2 pi to all of them. So let's check it out. To find local max and local mins, I will certainly differentiate once. And therefore x is this. Well, that's one of them anyways. And so I think we have local maxes at an infinite collection of x values. That's simply the first one. So now to generate the rest of them, I think I'm merely going to take 2k pi and add it to that single one. And that's going to be true for all values of k ranging over the integers. I think likewise, I got local mins at x values that are going to be, well, this one over here, which can be obtained just by looking at in a unit circle, where I'm going to actually generate a second y value whose sign is positive 1/2. I said y value. A second angle for which the sign's positive 1/3 in this case. Well, here's the inverse sine of 1/3 in the first quadrant. So the angle in the second quadrant whose reference angle is positive 1/3. So the angle in the second quadrant whose reference angle has a sine of 1/3 certainly is simply going to be this one right here, the inverse sine of 1/3 taken away from pi. And then I'll add on all integral multiples of pi. I don't know, everybody. Maybe I'm making a little too sloppy. Should I just simply cut to the chase and say I've got negative inverse sine of that 1/3, if you could read a sloppy writing, increased by the first and third terms? When I pull out a pi, does that give me a 2k plus 1? And then I've got my pi, and that's true for all k ranging over z. Now, if I want to come in and talk about where the inflection points are, piece of cake. Gosh, you guys, I hope that's okay. Just in case you can't read that, that's pi minus inverse sine of 1/3 plus 2k pi for all k and z. Here's a 2k pi plus inverse sine of 1/3 for all k and z. Just in case I'm being too sloppy, I'll try to slow down. Lastly, for me to find the x coordinates of all the inflection points, piece of cake. Differentiating this piece. And that's going to happen at all values of x, for which the cosine is going to be equal to 0. But the cosine is equal to 0. Pi halves plus 2k pi. And if you don't mind, I'll stop there. I want to identify where the changes me from concave down to concave up or vice versa. I was simply having a little bit of fun with a trig function, generating the x coordinates of all the inflection points.